In this lesson of ACT Math, we will discuss geometric sequences, the formulas you need to know, and the problems you will see on the ACT exam. With geometric sequences, this is where a sequence where there's a common ratio between subsequent numbers in a sequence. So we have the generic A, and then A times R to the first power, then A times R to the second power, A times R to the third power. So R is your common ratio. So if you look at this sequence, 2, 4, 8, 16, 32, 64. To find your common ratio, you just take the last number and divide it by the previous one. You can see that is 2, so our common ratio is 2. So you could write it as 2, and then 2 times 2 to the first, and then 2 times 2 to the second, and 2 times 2 to the third, and so on. So if you look, 2 going to 4 is times 2, 2 going to 8 is times 4, 2 going to 16 is times 8, or times 2 in between. Now your common ratio could also be a fraction. If we look here, we have 1/2, 1/4, 1/8, 1/16, 1/32, 1/64. We can see the bottom numbers are being multiplied by 2 each time. So our common ratio here is 1/2. We're multiplying by 1/2 each time. So here we basically have 1/2, and then 1/2 times 1/2 to the first power, and then 1/2 times 1/2 to the second power, and so on. And your common ratio can also be negative. You see here go from 2 to -4, +8, -16, +32, -64. So again, you just take the last number, divide by the previous. I think it's just -2. So our common ratio here is -2. So here we can write it as 2, and then 2 times -2 to the first power, 2 times -2 to the second power, 2 times -2 to the third power, and so on. Okay, so when we have an even number of negatives, we get a positive number. If an odd number of negatives, we get a negative number. So we see it switching from positive to negative, positive to negative. Then your common ratio has to be a negative number. Now the formula you need to know is this one. AN equals A1 times R to the n minus 1 power. Okay, so AN is your nth term. A1 is the first term. And R is your common ratio. And remember, n, we're going to find a 20th term, n is 20. So this is the term number. So here it asks, find the 20th term of the following sequence. So you can see it goes from 2 to 6 to 18 to 54. You can just take 54 divided by 18. And that gives you 3, so our common ratio is 3. So you could either keep on going until you get to the 20th term, but you don't want to waste a lot of time and figure out all those. So what we can do is come up with the equation and then plug in 20 for n to find the 20th term. So we know AN is equal to A1, the first term, 2, common ratio 3, and then to the n minus 1 power. So the 20th term will equal 2 times 3 to the 20 minus 1 power, or 2 times 3 to the 19th power. So you put this in a calculator, you get 2, 3, 2, 4, 5, 2, 2, 9, 3, 4. So this is a huge number. You're multiplying by 2 each time, so once you get to the pretty high numbers, you're multiplying big numbers times 2 to get to this value. So that's how you find the nth term. You can come up with a formula for it, and then plug in your n value. So this formula is used to find the sum of the first n terms of your geometric sequence. We have a1 times the quantity 1 minus r to the n power divided by 1 minus r. So I'm not going to use this formula to find the sum of the first 10 terms of this sequence. So we have a1 is 2. We have 1 minus, common difference is 3. So that's going to be to the 10th power over 1 minus 3. If we do that, we get 59,048. And there's also something called infinite series summation. This occurs when your r value is in between -1 and 1. So basically a fraction. So if I see the sequence 1/3, 1/6, 1/12, 1/24, you see the bottom is multiplied by 2 each time. So our common ratio is going to be 1/2. So if I keep adding these all together, these are going to converge into a certain number. So that's what this infinite series is supposed to do. So I use this formula a1 times 1 over 1 minus r. Our first term is 1/3. We have 1 over 1 minus 1/2. Alright, so we're talking about an infinite series, so if you keep on doing this infinitely, these are going to converge to one number. If you multiply this out, you get 2/3. So this series is going to converge at 2/3. Alright, so now we get into a typical geometric sequence you would find on the ACT exam. So it says the first and second terms of a geometric sequence are 12 and -4, respectively. What is the sixth term? So we have 12 and -4. So how do we go from 12 to -4? Yeah, divide by 3, -3, or times -1/3. So that's our common ratio. So we have an equals a1 r to the n minus 1. We know a1 is 12. Common ratio is -1/3. And we're going to find the sixth term, so 6 minus 1, or 12 times -1/3 to the 5th power. That's going to give us -4 over 81. So that'll be our sixth term of this geometric sequence. And this problem says the first term in the geometric sequence below is -1. What is the seventh term? Okay, so we got term 1, 2, 3, 4. I'm going to take the 216 and divide by -72. That's going to give me -3. So our common ratio is -3. So again, I come up with our formula. A1 is -8. Common ratio -3. We can find the seventh term, so 7 minus 1, or -8 times -3 to the 6th power. That's going to give us -5,832. So that's going to be our seventh term. So here's another example ACT problem. It says the first and fourth terms of a geometric sequence are 7 and 56 respectively. What is the sixth term? Alright, so this time they give us the first and the fourth. So we're missing the second and third one. But we want to find what the sixth term is. So again, we need to find a1 and our common ratio. We know a1 is 7. So we can use this formula. We can use the an equals a1 r to the n minus 1. So we use a4. We know that's 56. We know a1 is 7. Common ratio we don't know. And we know n is 4, so 4 minus 1, or 3. So we set up our equation, we can solve for r. So if I divide both sides by 7, I get 8 equals r to the 3rd power. Now to solve for r, I'm going to take the third root of both sides. And we know for a is 2 times 2 times 2, so r is going to equal 2. Now we can set up our formula. AN is equal to 7 times 2 to the n minus 1 power. So A6 will equal 7 times 2 to the 6 minus 1 power, or 7 times 2 to the 5th power. And this will give us 224. Alright, and this problem says, what is the sum of the first 12 terms of the geometric sequence shown below? Okay, so first we need to find our common ratio. We just take the 54 and divide by negative 18. This will give us negative 3. We're doing a summation, so this is S of n equals A1 times 1 minus R to the n over 1 minus R. So R was negative 3, A1 is negative 2, so negative 2 times 1 minus negative 3 to the 12th power over 1 minus the negative 3. And if you put that in your calculator, you get 265,720, or 265,720. And this problem says, what is the sum of the infinite geometric sequence? So remember, this one is going to be, our sum is going to be equal to A1 times 1 over 1 minus R. Okay, to find R, you take the 1 over 108 divided by 1 over 36. That's going to give us 1/3. So R is 1/3. A1 is 1/4. So 1/4 times 1 over 1 minus 1/3. That gives us 0.375. If you convert that to a fraction, that becomes 3 over 8, 3/8. Now this is an example ACT problem you would find. Here to give you the equation for the summation A over 1 minus R. This is dealing with an infinite geometric series. So it says the sum of an infinite geometric series with first term A and common ratio R less than 1 is given by A over 1 minus R. The sum of a given infinite geometric series is 200 and the common ratio is 0.15. What is the second term in this series? Okay, so we need to use our formula. We said that was S equal to A over 1 minus R. The sum was 200. Then we have our A, and then 1 minus 0.15. So that's 200 equals A over 0.85. Multiply both sides by 0.85. You get A is equal to 200 times 0.85, which is equal to 170. So A is our first term. So we have 170. Then to get the next term, we multiply it by our common ratio, 0.15. That's going to give us 25.5. So answer choice A. So to summarize, to find the nth term of a geometric series, AN is A1 times R to the n minus 1 power. To find the summation of the first n terms, that's the n equals A1 times the quantity 1 minus R to the n power over 1 minus R. Then to find the sum of an infinite geometric series, we said that was basically A1 over 1 minus R. So I hope this video helped you out understanding geometric sequences. Check out our other videos that cover many topics that are found on the ACT exam. Thanks.